The question which is coming from energy as well as the combination of energy as well as oscillation. So the question is saying figure 15.9 shows the potential energy diagram and the total energy line of a particle oscillating on a spline. Alright, so on this side here we have the energy. This line here which is drawn horizontally like this one is the total energy. We also have the curve for the potential energy which is drawn like this. So from what we have here, we have the first question which is saying what is the spline's equilibrium length. So as you can see, in the x-axis we have x, okay, so in the x-axis we have x, which is representing the length. So we have x, which is representing the length in centimeters. So a point where we are going to have equilibrium is a point where the curve of the potential energy is going to balance, meaning to say this side is going to be balanced with this side here, and that point is going to be 20. Since it is in centimeters, I need to convert that into meters. So we have 20 centimeters, which is approximately 0.2 meters. So this is our answer. That is where there will be equilibrium here. Now, for the second question, it is saying where are the turning points of the motion and explain. So when you talk of the turning points, you talk of where the curve of the potential energy is now passing through the total energy line. So this is the total energy line. Now where the curve of the potential energy is passing. So we have the first point, which is this one. So if I were to draw the dotted line going down here, this is the point. Then on this part here, if I draw a dotted line, this is going to be a point. So what are those points of the turning point? So if this is 12, this one is going to be 14, this one is 16. So we have 14 here centimeters. If this is 24, this one is going to be 26 centimeters. Now we are talking about the turning point, so it has to be in coordinate form. So the first one, this one has to be expressed as the length, potential energy, okay, or total energy. So in this case, the total energy, since this one is 5, this one has to be approximately 6. So we can start with the first one. So the first one is 14 centimeters, 6 joules. And the second one is going to be 26 centimeters, 6 joules as well. So these are the turning points. If you want, you can convert them into meters. So meaning to say, this one is going to be 0.14 meters. This one is going to be 0.26 meters, 6 joules. Now in terms of the explanation, you know to say that this is the total energy line. So meaning to say, the turning point is formed where the potential energy curve passes through the total energy curve. This means that the object is oscillating back and forth between 2 points. So meaning to say that if this is oscillating, or we are talking about oscillation, if an object goes like that, it is going to bounce, or it is going to move back forth like this. It is going forward and back forth between 2 points. So that is one thing that you need to know. That is the explanation. This is because turning points, or the turning point is formed where the potential curve crosses the total energy line, and this means that the object is moving back and forth between 2 points. So question C, what is the particle's maximum kinetic energy? So we have total energy here, which is equal to kinetic energy plus the potential energy. So we are finding the kinetic energy. So we can say kinetic energy is going to be equal to total energy minus potential energy. So from there, what are we going to do? We know to say that what is the total energy that we have? The total energy is this one here, where the line is being drawn for the total energy, which is approximately 6 joules. So if we say kinetic energy is equal to the total energy. So total energy, if you use the law of conservation of energy, it doesn't change. Okay? Doesn't change. So you're going to find that if the potential energy at this point here was 6 joules, even the kinetic energy here is going to be 6 joules, because we know to say that the potential energy decreases as the height is decreasing also. Or we can say the potential energy is at lowest at the equilibrium. So meaning to say at this point of equilibrium, we are going to have the potential energy being equal to 0 joules. But for kinetic energy, it is going to increase. So meaning to say for kinetic energy, we have 6 joules at this point here. So that is one thing that we need to know. So the total energy that we have is 6 joules. The potential energy is just going to be 0 joules. As the result, what are we going to have? We're going to have 6 joules as our answer. For question D, what will be the turning points if the particle's total energy is doubled? So the total energy that we have is 6 joules. So if this one is doubled, so we are multiplying by 2, it is going to be 12 joules. So that is 12 joules. So we can just imagine that 12 joules is somewhere here. Then I need to draw a line for the total energy. Okay. So this is our total energy line. So in terms of the turning points, what are the turning points are we going to have? So if I draw a straight line going downward here, going to find that I'm going to reach at 12. Then when I go down here, going to find that I'm going to reach at 28. So in terms of the turning points that we are going to have, the first one, we are going to have 12 centimeters, 12 joules. So in this case, you can convert that one to be 0.12 meters, 12 joules. Then the second one is going to be 28 centimeters, 12 joules. So if you convert that, it is going to be 0.28 meters, 12 joules. So those are the coordinates, the first one and the second one. So that is how you're supposed to answer that one.